Hello, my name is Cello Itasic. I'm from Metropolitan's Information Technology Group. I will introduce you to the Wadsworth Pump Plant Control and Protection System Upgrade Project.
At a first glance, Wadsworth facility may look like one of many dams and power generation facilities. However, if during a visit to one of these other facilities you ask the hosts, "Can you now put the water back into the lake using the same units?" a question like that may raise a few eyebrows. At Wadsworth, this is part of core functionality. Wadsworth generates energy when water is released through the turbines and can use the same turbine units to pump and lift water from the forebay into the lake. The ability of units at Wadsworth to both pump and generate is enabled by a system that includes a number of controllers, which are computers hardened for use in the field and connected to instruments and equipment. Controllers receive data from sensors that measure things like flow, vibration, pressure, and they are programmed to issue commands and control the equipment. There are a number of such controllers at Wadsworth, and they all have to communicate with each other. The operation of Wadsworth has been automated and requires little human intervention. Some of the equipment in Metropolitan's system has been around for decades and it still operates well. However, equipment that includes sophisticated controls requires more frequent updates. Advanced technology has a much more limited lifespan. Few of us have the same cell phones today that we used 10 years ago. The driver for the upgrade of the Wadsworth pump plant was the obsolescence of the control system technology, the part of the plant that is most advanced and the most vulnerable to aging. Staff kept the plant running effectively well beyond the expected lifetime of the complex technology components of the control system. The upgrade was completed in summer of 2020. After several rounds of extensive testing, all engineering documentation has been reviewed and accepted, and the plant has been accepted for beneficial use. The upgrade of the control system was also an opportunity to streamline and standardize the system components. New equipment is consistent with current industry standards and best practices, and the new components at Wadsworth are compatible with the existing components that Metropolitan is using in the rest of the system, including conveyance, distribution, and treatment plants. To illustrate the simplification and streamlining, let's look at what a control cabinet used to look like in the old system. The old cabinets included a number of old-fashioned indicators and gauges. An annunciator panel was used to indicate the events that operators should know about. These types of indicators were hardwired through complicated wiring. The new panels include computer screens that show more information in a more flexible and user-friendly way. So the wiring inside the cabinet is now much simpler and cleaner. For example, all the wires that were required to power up the different annunciators were now replaced with only a couple of cables. This project required different types of expertise, and the most significant success factor was the active engagement and collaboration between different Metropolitan staff from operations, engineering, and IT. Metropolitan staff performed a number of critically important tasks using in-house forces, and their diligence and commitment was the key to the success of this project. Staff performed the work that would otherwise have to be performed by a contractor, this including disconnecting and reconnecting around 6,200 wires in the plant. A key partner on the project was the consultant. who performed the engineering work and coordinated a number of different vendors who were providing different system components. Metropolitan implemented a rigorous system for the review of all the deliverables and submittals and maintained a productive relationship with the dedicated professionals on the consultant's team. Technology projects of this type are complex and include some inherent risks. Our project management approach was based on identifying and proactively mitigating such risks. This helped us avoid costly mistakes and execute the project effectively. We used prototyping and piloting to test key design decisions and included the lessons learned as we raised the implementation from prototype to full scale.
This drone video was taken during our pump testing. It is inspiring to see the plant running after all the effort and hard work. Please note that the water was pumped from the forebay and then returned back to the forebay through the cone valves. This enabled the project team to fully test the pumping functionality without introducing any CRA water into the lake. The plan had to be reconfigured by plant staff for each series of generation and pumping tests. This was a truly collaborative effort by Metropolitan staff from operations, engineering, and IT. All of us are delighted that this facility is now fully operational and will remain so for years to come.